Okay, this is a model of a building that I constructed, which would actually be able to withstand simulated earthquake shaking. So if we kind of look at the bottom of the building, and that might be the easiest thing to look at first. In this system, this would be constructed on the bottom. This section actually would go underground and you wouldn't see it. The whole model is made out of wood, but that is still yet simulated for other things. So, for example, these circular ball-shaped objects would actually go under the ground and they would be made out of rubber. And with all of the research I did and all of the experts I talked to and, talking with my husband and things, we were discussing how rubber would actually help reduce some of the shaking and the movement that the building would experience. And this would just be attached to the building, as you can see. It is here in this example, but it would be under the ground, so you wouldn't actually see it. The next thing that we kind of come to is on each of the sides, you notice that there is a vertical beam that kind of helps support and connect the top and the bottom. But there's also like this X beam here also. And an X beam is just there to actually help support the building better. You notice that there's one here on this side. There's a slightly smaller version of it on this side. Again, a bigger version of it on this side, and once again, a smaller version on this side. There's actually that same concept towards the roof part of the building to actually help support the building so that even if the roof were to collapse it would still yet help be supported here so that it didn't go further down into the building and cause whatever destruction or unfortunately loss of life sometimes. So I have placed this on my simulated shake table, and we're going to imagine for a moment that this here is maybe our fault line, and our building happens to actually be resting on that fault line, and then the fault lines are going to collide and shake and move as it would in an earthquake. And we're just going to simply see if this building passes the test of being able to withstand all of that. Now, again, typically everything in this building could actually be made with the same materials that it is right now, except for the bottom portion, which again they could be made out of a material like rubber or steel or something else that would help make it structurally more sound. Okay, so let's do our simulated earthquake and just kind of see what happens. I felt like I, did get pretty violent with the two tables. And again, you see that they did kind of overlap here, as it might when you have the tectonic plates going over top of each other. At certain points during the simulation, they were also away from each other. You see that the house did move slightly. It probably would have been less likely to do that had it actually been in ground somewhere. But again, of course, it's not dug into a hole inside a ground somewhere. So it probably actually would have done even better had it been down within the ground somewhere. But even still yet, with it completely not buried and dug in as it typically would be, it still was able to withstand it very well. Although the house moved, it did stay structurally sound. You can tell that the houses, or the model I should say, I guess it could be any kind of building, but that the model stayed intact. There was no breaking or falling apart anywhere on the house. So it actually did withstand it pretty well. Had I made it with maybe flimsier materials, it may have. But this model, I would say, definitely does pass the shaking table. It didn't collapse. So we're going to call this one a success.